Good day, class. So, I am your teacher today. This is Carol Sewell. I'm your teacher in geometry. So, before we start our lesson, please stand for our opening prayer.
Dear Heavenly Father, we thank you for gathering us all today in this important endeavor. We ask that you bestow your guidance and blessing upon each attendee. May we honor one another by keeping an open mind. May we voice our truth and listen with an open heart. Bless everyone present today, that each may be able to share his or her contributions and gifts. Grant good health and safety to loved ones left outside this room, and bestow peace and goodwill to all of us. We ask for your wisdom and grace to use our talents for the betterment of others. May the various activities related to this day be a success through your intervention. With gratitude, we offer this prayer in your name. Amen.
So, you may now take your seats. So, before we start to discuss our new topic, so let's have a quick recap for our previous lesson. So, I have here three equations, and then you must name these three equations or what property this three equation is. So the first is if A equals to B, then B equals to A. What property is this? Alright, yes, that's correct. It's symmetric property. Then the second one is if X equals 5 and Y equals X, then Y equals 5. What property is this? Good job. It's a transitive property. So the last one is 3 times x plus 2 equals 3x plus 6. What property is this? Or what property of geometry is this? Yes, that's correct. It's distributive property. So now, since you already know, since you already recall our previous lessons, so before I introduce the new topic, so let's have an activity. Okay, are you ready? So our next activity will be the class will be divided into 3 groups. This is the group 1, the group 2, and the group 3 at the center. So I have here I will provide a scenario, or yes, a scenario, and you must answer, you must create your own reasons or an evidence to support the scenario. Okay, so you may write the scenario in any piece of paper. Okay, so the scenario is you tell your parents you deserve a letter curfew. Tell your parents you deserve a letter curfew. Okay, so in that situation, you have to create your own evidence. I mean, you have to create an evidence to support your statement. Yeah. Okay. So let's start for the group 1. Okay, very good. So, as what I have said earlier, that you have to create your own, each group must create your own reasons to support your evidence. So, now in geometry, we don't just say, in geometry, we don't just say the things are equal, because just because they look like equal, but we have to make, I mean, we have to support our evidence using a mathematical investigation or mathematical proof. Okay, that's right. So now we have to proceed to our activity 2 with the same three groups. So I will provide the three sentences, and you have to connect the three sentences into to form a one sentence. Okay. Uh, uh, in the same manner, you can write the sentences. I mean, you can write the sentence in any piece of paper. Okay. So the first um, I, so the first sentence is, it is raining. It is raining. That's the first sentence. The second sentence is, the grass is wet. The grass is wet. And the last one is, therefore, I should buy a boat. So, to connect that three sentences uh, to connect the three sentences to form a one sentence, you have to prove, you have to analyze the sentence first, then jump into a conclusion. Okay, time starts now. Okay, alright. As I have observed earlier, you create your own sentence and you have your own evidence. So, let me ask you, where did the logic fail? Those based on the three sentences, where does the logic fail? Okay, you have to don't have to jump into conclusion, but you have to find evidence to support your claim that that is true, right? Okay, let's go. That's correct. So, are you ready uh for the proper lesson? Do you have any idea what our new topic for today? Okay, let's start. Based on the activity, when do we say that the statement is correct? Okay, yes, that's correct. We have to find the valid evidence to support our claim, right? Okay, that's correct. And in geometry, we begin with given and prove statement, which restate that the hypothesis and conclusions of the statement. Yes, that's right. It's we have as you have said, we must find the valid evidence to support our claim, right? Okay, so now let's move on to our main topic. So our main topic is about the two-column proof. So what is the two-column proof? Two-column proof is a structured logical argument used in geometry to prove that a mathematical statement is true. Yes, that's the property. I mean, that's the a rule of two-column proof. Okay, it is organized into two side-by-side columns that is separated the what from the why. Okay, basically, the what portion was the statement or the given, or the given, and the why is the must be the evidence. Okay, think of it. Think of it. It is like a trial age. Yeah, and the statement is your evidence, and the statement is your evidence. And the reason is the law that makes your claim valid. And a given, the information provided to you as true. This is the starting facts. The and to prove the specific conclusion you are trying to reach. So the statement is, for example, the angle of A is a right angle. So the reason is it is true because it is the given and always in the starting point, as what you have said. As what I have said, that the given is the starting point. And then the second one is the measure of angle A is 90 degree. So that it is true because this is the definition of the right angle, since the right angle is measured into 90 degree. And this is the rule that justifies the statement. Okay. So I have here uh, three questions. So why do we use the two column proof in mathematical and geometry? I mean, so why do we use the two column proof? Yes, that's correct. The two column proof is are used to establish the truth of a logical statement or the mathematical argument. This process involves using a combination of axioms, postulate, and theorems. That's why we need to use the two-column proof to provide, I mean, to to prove that our claim is true. Then, what are the three proofs in the geometry? What are the three proofs in geometry? So the first one is the two-column proof. This is our topic for today. And then the second one is the paragraph proof. The paragraph proof is you just have to write it in column but in the paragraph form. And then the third one is the flowchart proof. Flowchart proof is like a two-column proof, but only it is defined into three or more charts. Okay, so those three proofs in geometry states that each of these methods can be employed to demonstrate a logical argument or to prove the statement validity. Okay, so the third one is, what is an example of the two-column proof? So the two-column proof is provided as an example provided as a process of proving the congruence of two triangles. Okay, the two triangles. This involves using available information and any of the five triangle congruence theorem to determine if a triangle is congruent. So that's the example of the two-column proof. So we're learning to write how to do proofs in geometry and writing two-column proofs. First, look at any provided information that may be given. Any provided information that may be given. This includes any given statement or information given within the proof diagram. When writing, all pieces will be on the left side. When writing all the pieces of the proof, develop a two-column proof in which statements will be on the left side of the left side columns and reasons in the right side column. And then the proof will follow a chronological and logical order with the statements. Fill out the proof with any given information and state the reason as a given. That's the universal first step on how to write a two-column proof. When determining how to complete the proof, determine how to prove the overall statement, find useful and needed information to complete a logical argument. Yes, to determine how to develop a conversation using the two-column proof table format. So the two-column proof must be this. Okay, so these are the four elements of two-column proof. This is the first one is a mathematical statement written in the first column. So this is the first column of the top column proof. And the second one is the reasons explaining the statements written in the second column. This is and the left side will be the statement form, will be the statement. And the second, the right side is will be the reasons. And then the third one is the logical order. Statements are numbered and follow a logical sequence. These are the logical order. And the conclusion, the proof must end with concept being proven. So the conclusion must written below the two-column proof. So this is how it looks like. This is the statement, the left side, and the reason it will be in the right side. The logical order, which is the numbered and follow a logical order. And then the conclusion will be below the two columns. Okay. So I have here an example. So a triangle congruence postulates are geometric rules used to prove that two angles are identical in shape and size. So this is the shape and this is the height. Okay. Without checking all 6 corresponding parts or the 3 sides and 3 angles of the triangle. Okay, that's what we call a triangle congruence. Then the complementary angle is a right angle that has two angles that are two angles that sum up into 90 degrees, forming the right angle, while supplementary angles are two angles that sum up to 180 degrees, forming straight line. So complementary angles often form a corner, and the supplementary angles often form a straight angle. Okay, this is the angle congruence. This is the complementary angle, which the measure of angle A plus the measure of angle B will be 90 degrees. So basically, angle A is 45 degrees and angle B is 45 degrees. So that would be 90 degrees. Then the supplementary angle is measure of angle A plus the measure of angle B equals to 180 degrees. Supplementary angles is more than twice the complementary angle. Okay, the complementary angle is like this. Okay. This is the complementary angles, the measure of 90 degrees, and then the supplementary angles will be this. This is the 180 degree. It is twice the angle of complementary angle. Okay, now let's proceed to the angle congruences. So the angle congruences, first we must look into side angle. So what is the side angle? So the side angle, when the 3 sides of a triangle are equal to the other 3 sides of another triangle. So this one, they have a different size. I mean different size. Okay, so say side, side, side. That's the what we call a angle congruences or the side congruences. The 3S or the SSS or the side angle, which is the three angles. I mean the three triangles. The three sides of a triangle. Three sides of a triangle is equal to another triangle. So this one, this is the angle A, the angle A, the angle B, and the angle C. And the other side is this is the angle Q, angle P, and angle R. This is the what we call the SSS triangle. So the next one is the SAS, or what we call the side angle side congruence. Okay, so the side angle side congruent is when the two sides and the included angle on one triangle is equal to the two sides and included angle to another triangle. So okay, this is what we call the side angle. This is the two sides are equal and the other two sides are equal and they have the same angle, which is equal to 90 degree. This is the 90 degree, right? This is 90 degree and this is the 90 degree. So the third one is the angle side angle. So it is the opposite of side angle side. Angle side angle congruences is when the two angles and the included side are equal to the another side of the other triangle. Okay, this one we have okay, so the angle side angle is again this is the two angles and the included side of one triangle are equal to the two angles and the included sides of another triangle. For example, this is the angle A, B, and C. This is the angle Q, P, and R. This is angle A is congruent to angle Q. This is the angle Q. And then angle B is congruent to angle P. So they are congruent, right? So they have the same angle, which is the 90 degree, and the third one is they have the side. I have a side. Okay, that is what we call the angle side angle. So the fourth one is the angle side congruences. Angle side is when the two angles and the non-included side of a triangle are equal to two angles and the non-included side of another triangle. So it's this. Okay. Okay, this is the example. Again, this is angle A, angle B, and angle C, angle P, Q, and R. So this, in this situation, this is the angle C. Angle C is congruent into angle R. They are congruent. And then the angle A is congruent to angle B. Okay. And then the sides, this is the sides. They have the same sides. They have the same angles. So that's what we call the angle side. So the next one is the RHS. What is RHS? We call the right angle hypotenuse side. Again, this is right angle hypotenuse side. Even the hypotenuse have a long length, that is the long length of our right triangle. Okay. So this. What is the RHS? The RHS is when the hypotenuse and one side of a triangle, of a right triangle rather, is equal to the hypotenuse and other side of another triangle. So it looks like this. This is our hypotenuse. And then this is our angle B and angle Q. They are congruent. They have the same length. They have the same hypotenuse, right? So they have the same sides. This is the same side. They are congruent at the same side. Like they have the same length and the same sides. And that's what we call the right hypotenuse, the right angle hypotenuse side. Again, this is when the hypotenuse and one side of a triangle is equal to the hypotenuse and the other side of another right triangle. So those are the 5 congruence of a triangle. So the next one will be, okay, since you already know that 5 triangle, the 5 congruence of a triangle, the SSS, again the SSS will be the side congruence of a right triangle. And the second one is the side angle side, which is the side angle side congruences of a right triangle. And the third one is the ASA, the angle side angle congruences. The fourth one is the angle side congruences. And the fifth one is the RHS, the right angle hypotenuse side. So let's proceed. So I have here 3 questions based on our topic being tackled today. So first, why can't we just write down the answer in a proof? Why? Yeah, it is because in mathematics, in geometry, the proof is about the process, not just the result of your statement, not just result of your answers. Okay. In geometry, we must demonstrate that the conclusion is under denial by showing every logic link in the chain. So we have a chain, or the process in solving that specific mathematical argument. So the second one is, what are the 4 elements of 2-column proof? Again, what are the elements, the 4 elements of the 2-column proof? So the first one is the mathematical statement. Mathematical statement will be written in the first column. The second one is the reasons. So the reasons explaining the statement written in the second column. The third one is the logical order, or the numbered sequence. The numbered that followed by logical sequence. And the last one is the conclusion written below the two-column proof. Okay, that's right. So now I have here another example. Okay, proving congruence triangle, or prove the following triangles using two-column proof. Prove that measure of angle ABE is congruent to angle DCE. So this is what it's like. Angle of A, okay, this is the angle B, the angle A, angle E, angle C, and angle D. Okay, as you have seen in the example, we have this is the two. They are congruent. The BE, the first one is the BE is congruent to CE. Yes, they have the same sides. They're congruent in two sides. So the next one is AE is congruent to DE. Yes, it's congruent to DE. Because they have the same sides. Okay. Now, the angle 1 is congruent to angle 2 because they have the same angle, which is the 90 degrees, or we can use the 40 to 45 degree. Okay, or we will be using the complementary angle, which is the 90 degree. So they are congruent. So the condition here is prove that angle A, B, and E is congruent to angle DCE. What? The A, B, E is congruent to DAC. Yes, they are congruent because they have the same sides, they have the same two sides, and they have the same angle, which is this is the SAS postulate, or what we call the side congruence of a right triangle. Okay, that's correct. So now let's wrap up. So are you ready for our quiz? A short quiz. 4th sheet of paper. And in a 1/2 crosswise, write your name, the date today, year, and section. Don't forget to number your paper. And 2, we have the 5 items multiple choice and the 3 items for proving. Okay, start. Question number 1. In a 2-column proof, what is the primary purpose of the left column? A. To provide the final answer to the problem. B. To state the mathematical steps or claims being made. C. To list the logical justification or rules. Or letter D. To summarize the problem's background. Again, in a 2-column proof, what is the primary purpose of the left column? The left column is here. Okay. A. To provide the final answer to the problem. B. To state the mathematical steps or claims being made. Letter C. To list the logical justification or rules. Or letter D. To summarize the problem's background. So, number 2. Which of the following is always the first statement in the standard two-column proof? A. The reflexive property. B. The conclusion of the argument. C. The theorem to be proven. Or letter D. The given information. Again, which of the following is always the first statement in standard two-column proof? A. The reflexive property. B. The conclusion of an argument. Letter C. The theorem to be proven. Or letter D. The given information. So number 3. What does the right column of the two-column proof contain? What does the right column of the two-column proof contain? Letter A. The names of the shapes being studied. Letter B. Calculation and sketchbook. Letter D. Definition, postulates, and theorems. Or letter D. Description of the diagram. Number 3. And again, what does the right column of the two-column proof contain? The right column here. Okay, this is the right column. Letter A. The names of the shapes being studied. Letter B. Calculations and sketchbooks rather. Letter C. Definition, postulates, and theorems. Or letter D. Description of the diagram. So number 4. Why is it important to use reasons in a two-column proof? Letter A. To show that each statement follows from a previous accepted rule. Letter B. Because the teacher requires it for points. Letter C. To provide a translation for the math symbols. Or letter D. To make the proof look more professional. Again, why is it important to use reasons in a two-column proof? Letter A. To show that each statement follows from the previous accepted rule. Letter B. Because the teacher requires it for points. Letter C. To provide a translation for the math symbols. Or letter D. To make the proof look more professional. So this is the last number for the part 1. Number 5. What is the very last statement in any completed two-column proof? Again, what is the very last statement in any completed two-column proof? A. A repeat of the given statement. B. The proved statement. C. The definition of congruence. Or letter D. The QET. Again, what is the very last statement in any completed two-column proof? Letter A. A repeat of the first given statement. Letter B. The proved statement. Letter C. The definition of congruences. And letter D is a QET. Okay. Now, let's have prove that the triangle congruence using a two-column proof. This is the angle G, M, angle K, and angle L. So, now, the number 2 is prove the triangle congruence using the two-column proof. So, the same manner, you have to prove the three angles, and I mean the three triangles. And okay, time is up. Exchange your papers. 1, 2, 3, 4, 5. Okay, number 1. A two-column proof. What is the primary purpose of the left column? Okay, X letter boy. State the mathematical steps or claims being made. Number 2, which of the following is always in the first statement in the standard 2-column proof? The answer is letter D, the given information. Yes. Number 3, what does the right column or the 2-column proof contain? Answer is letter C, definition, postulates, and theorems. Number 4, why is it important to use reasons in a 2-column proof? Why? So answer is letter A, to show that each statement follows from previous accepted rule. Okay, number 5, what is the very last statement in any completed 2-column proof? Answer is letter B, the proof statement. Now we have our proven. Okay, answer is the G, the angle, and ano siya? Okay, we have the angle M, the angle A, angle P, and angle L. So, basically, the angle G and M is congruent to angle L and K. Okay, so next is angle M and L is congruent to angle G and R. Okay, then the last is angle GMK is congruent to LMK. Yes, they are. This is what we call the SSS postulate side because they have the same side. Have the same side here, and yeah, enough. Yes, side postulate. So the next one is the number 2, the angle Z. The angle Z. We have the angle Z, the angle W, angle S, and the angle T. So they have the same sides. Okay, same sides, side, and side. So angle Z and W is congruent to angle D and S, and W to D is congruent to Z and S. So basically, this is the side postulate. Okay. The third one will be the we have the same. We have the angle A. We have the angle A, N, G. We have the angle R, W, and T. So angle T and W is congruent to A and N. So angle G and N is congruent to angle of A and N is congruent to R and W. So the side of G and N is congruent to P and W. And then we have the equal side. The N and T W. Where's W? Here. They have the same angle. This is what we call the SAS postulate which is the side, they have the same side, then they have the same angle. The sides, angle, and the sides. Okay, count the number of checks and return your paper. And 5, 4, 3, 2, 1. Okay. The 0. Okay. So, since you already know how to prove your mathematical statement and how to write a two-column proof using given formula and true. So, I have one more question here. If you stack at the beginning of the proof, what is the universal first step? Again, if you stack in the very beginning of the proof, what is the first step what is the universal step of the two-column proof? Yes, that's correct. The universal first step of the two-column proof is you have to look for the given first, the given information rather. Okay, and write it as the statement. This is the statement part will be in the left part. Okay, in writing a two-column proof niche. Okay, and write the given as the reason. Okay, this sets the foundation of the rest of the argument. That's how we write the first step of the two-column proof. Yes, that's the first step. And now, since you already know, we already tackled our lesson for the day. That is all about the two-column proof. Now, and one half crosswise, prove the following, which is here are the angle C, angle A, and the angle B. So you have we have the given here. Angle A and angle C are the complementary angle. What is the complementary angle? Yes, it is sum up into 90 degrees. Okay. And the second given is the measure of angle B and angle C are complementary. Again, they are 90 degrees. Then now, prove that angle A and angle B, angle A and the measure of angle A is congruent into the measure of angle B. So, pass it tomorrow. And so, a round of applause for everyone. Okay, thank you for your cooperation. Thank you for your participation in our topic for today. Again, our topic is all about the two-column proof and geometry. Okay, it's a wrap. Thank you and God bless all.